Hello, Calc BC students. We are going to do a lesson from 2014, number 5. This problem is a BC problem. However, part A and part B would also be considered more of an AB. It's part C that makes it purely a BC problem. So I'm going to encourage you to pause the video and read that given information. So we have this shaded region that's bound by the graph y equals xe to the x squared. So I'm going to color that in. I don't think you can quite see it, so let me get a thicker pen here. This is this function. Okay. Then we have the line y equals 1 minus 2x. And then we have a vertical line x equals 1. And so that's the region that we're talking about. And the first thing we're asked to do is find the area. Before I do anything, I'm going to come through and find these points of intersection. So I'd like for you to pause the video right now and take the time to find those points. So I've put in the ordered pairs here in purple, and I've also made it very clear that this problem would be a non-calculator problem. Okay, so part A, we need to find the area of R. So I'm going to set this up as integrating with respect to x. When I think about my cross sections, all of my really thin rectangles would go top minus bottom, like this. Okay? And so I need to think about what creates the length of those little green thin lines, the height of those rectangles. Pause the video and take a moment and think about that. So you can see I wrote in the general ordered pair for this one green line here. And so when I think about the length of the rectangle, my top, or the height, top minus bottom, would be xe to the x squared minus negative 2x. So that's my length. What gives me the area of one rectangle is we have to include the width. And the width here is that change in x, that dx. So for part A, my area is going to equal, and I'll figure out the bounds later, xe to the x squared plus 2x. So that's this height of the rectangle that we found. And to get the width is dx. So my integrand represents the area of one rectangle. The integral gives me the sum of infinitely many. My bounds. Since I'm choosing to integrate with respect to x, I take the lowest x value, which is 0, to the highest x value, which is 1. So there's my integral. But now I have the challenge, since this is a non-calculator problem, I have to show my integration. So I have to find that antiderivative. So I'm going to encourage you to pause the video and see if you can antiderive this by hand, and then come back and check your work in a moment. Some students would be very comfortable integrating that xe to the x squared just as it is, but some of you won't be. Some of you would want to use a u substitution. Whatever the case is, that's okay. So my antiderivative is 1/2 e to the x squared plus x squared. And my bounds are 0 to 1. Remember, these are x bounds. I always want to think about that, because as a side note, if you chose to create this integral off by itself, and you chose to say, well, I'm going to do u substitution, right? And then you changed your bounds with respect to u. In this case, you would still have 1 and you would still have 0. But if those were different, you want to make sure you're integrating, you're using bounds that match your variable of integration. Okay, so now go ahead and evaluate your integral by pausing the video and then check your answers with me. So we would have been okay here. We didn't need to simplify, but I did simplify my answer. How would my point values break down? I'd have 1 point for the integrand, 1 point for the antiderivative, and 1 point for the answer. Okay, now we're ready to do part B, right? But do not evaluate. So if you get that on an AP test, don't evaluate. You're wasting time. An integral expression that gives the volume of the solid generated when r is rotating about y equals -2. So we got to think about that. So if y equals -2, I wrote this in here. I'm gonna move this up here. Y equals -2x. Y equals -2 is a horizontal line. So let me draw in my axes of revolution right here. So this is y equals -2. And so what we're doing is we're going to take, again, let's make that sliver. And we're going to rotate this. Now I'm not the best at drawing things, so please forgive the drawing. But I like to think about it as these separate points just kind of revolving. And you can see we've got that space between that region and the axes of revolution, and that's going to cause a washer. So the next thing we want to do is think about, well, when we think about the area of that washer, so if we think about a washer, we have the area of the big circle minus the area of the small circle. And some students will say, well, okay, I can factor out pi, but be very careful. Big R squared minus little r squared does not equal big R minus little r quantity squared. So be careful when you're cleaning that up. So we need to find the big radius. And so the radius is always drawn from the point furthest away from the axis of revolution. So let me think of a bright color here that I can use for us to see this. So this point right here, and it touches the axis. So this is my big R. Top minus bottom, since we're revolving around a horizontal line, and my thickness is dx. So big R is x e to the x squared minus that axis of revolution. Okay? My little r is that point closest to the axis of revolution, to the axis of revolution. So you could see that there in orange. So my little r is -2x minus the axis of revolution. So we have -2x plus 2. I want you to pause the video and set up your integral expression that will give you value. Here's the expression. I'm using some color coding. You could see that blue, which I like to call Tiffany blue, represents big R, and the orange represents little r. Don't forget the pi. If you're going to factor, make sure you have that pi. Now, whether it's in the integrand or factored out in front, that's fine. And never forget your dx, or if you're integrating with respect to y, your dy. Go ahead and take a moment and read part C. Okay, part C is the part of the problem that makes this a BC only problem. An AB kid would not be prepared to do this problem. So once again, we got to write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. So we need the length of Tiffany blue plus yellow plus orange. The yellow and the orange, we don't need calculus for that. It's the blue that we need calculus for. So I'm going to start my work with the yellow and the orange first. I would like you to pause the video and figure out the length of yellow and figure out the length of orange. You can see that I found the length of the yellow is e plus 2. And by doing the distance formula, I found the length of the orange as square root of 4. Or I'm sorry, take that back, square root of 5. So as I start thinking about my perimeter, the perimeter, at this time we have root 5 plus e plus 2 plus, that's what we got to figure out. So we need to figure out that length of the blue. And I'm going to refresh your memory. The length of that blue, in general, is going to come from this integral. So, I mean, we should know our bounds. Our bounds are from 0 to 1. But it's that dy dx that we need to find. So what we are looking to find is the derivative of x e to the x squared. Please pause the video and take the time to see if you can find that derivative on your own. So hopefully you remembered that that's a product rule. And you can see my work there. So I'm just going to clean it up a little bit. Now, I don't need to do anything more than that. If I want to leave it like this is totally fine. And I can go ahead and write my answer for this. I'm going to just go ahead and put this, and then I'll put it into my perimeter equation over there in a moment. I can write it like this. And I'm fine. With I need my dx. You will see on a College Board rubric them cleaning this up. That is not necessary. You can write it like that. So I just need to add that into my equation. I think I transferred this wrong here. I need to square that. Double check your work if you have time, because if you transfer something wrong like I just did, you're going to lose some points and it's not worth it. This is my answer. So where do your points come from? My points come from getting this derivative gives me 1 point. The integral, this entire integral here gives me another point. And then the total answer, that perimeter gives me my 3rd point. I realized in part B, I forgot to go through the point spread on that. So the point spread on this comes from that integrand of 2 points. Okay. And then my final answer, the limits in the constant of pi. So my next and last point come from that 0 to 1, and which are my limits, and then the constant. So these things here give me that 3rd point. I hope you're all having a good day. Please take care.